Okay, hello everybody. I am remaking this video because of the fact that the audio in the previous video was horrible and I had a lot of little errors that needed to be corrected, and I wanted to clean up my dialogue. So I created this intro section to the notes file, and I also uh, revised the notes section to include the dialogue that I did not include before. So let's see what happens this time. I decided to make this video because of what Jason on his channel Retro Islander is doing with AI. So, based on some of the things he said in his videos, I have decided to make notes and create some sample routines that will show us what happens. So these three test routines show the errors that occur when defining type, dim, and param statements incorrectly. This is why you have to be careful about how you declare your variables. I will start with the type example, then move to the dim example, and finally to the param example. So on the dim example, you notice when you load it, there is two errors. If I list, if I list the program, it shows that error 24, which is at address 0037, is at the dim fruit FRT statement. And the reason that illegal type suffix error happens is because Basic09 doesn't know what FRT is. The type statement doesn't occur until later. Error 00 or error 66 at 004B occurs at fruit.apple equals 4. The non-record type operand is because, as far as Basic09 is concerned, apple shouldn't be there. Fruit is a defined by use real variable. To correct this problem, all you need to do is move the type statement before the dim fruit statement. That will clear up both errors. Okay. Notice that if you define the type statement after you've tried to use the variables or after you've dimmed a variable to that type, it results in two errors. And then I explained that already, so let's continue. Okay, now we will do test dim. And you notice that it has three errors. And we list it. This time I'm going to use the intro. This procedure produces three errors. The first error is 76, multiply defined variable, at offset address 001A. The second error is 24, illegal type suffix, at offset address 0029. And the third error is 66, non-record type operand, at offset address 0044. You'll notice that two of these errors are the same as what occurred in the type example. The first error is dim var2 byte statement because var2 has already been defined by use as a real variable. The second error is the dim var3 typ1 statement because the type statement occurs after it. The third error is the var3.field1 equals 3 statement because var3 is a defined by use real, not a user-defined type. To correct these errors, the dim var2 statement needs to be moved before the var2 assignment statement, and the type statement needs to be moved before the dim var3 statement. And now last, we will do the param example. So this procedure produces a single error, 76 multiply defined variable at offset address 001A. This is the var2 equals 5 statement. The variable was declared as a defined by use real, so the param statement is considered to be a different variable. Also, defining the variable by use makes it a local variable, so the parameter variable would not be seen. To correct it, the param statement must be moved before the var2 statement, or even better, to the next line after the first param statement. More efficient is to combine both parameters into a single statement, param var1 colon integer semicolon var2 colon real. My preference for these types of statements is to put all type statements at the top of the procedure with the dim statement for each type immediately following its associated type statement. Following that are all dim statements for the variables local to the procedure. And finally, any param statements. If there is a type associated with a param variable that is not associated with any other local variable, I place the type statement before the first param statement, even if that statement is not the variable associated with the type. So that's my preference. Others have their own preference. Jason, for example, likes to have the param statements first, followed by the dim statements, and any type statements that are needed prior to the param statement. And that's fine. You can do it that way. So now on to the notes. Understanding how Basic09 works. A good understanding of Basic09 requires a good understanding of how it compiles the source code. Basic09 performs two passes over the source code when it loads it. The first pass looks for syntax errors and compiles the code while loading, and the second pass looks for compile errors after it loads. In the compile, Basic09 converts the source text statements into a form called I-code. I means intermediate. In I-code, keywords are replaced with tokens, byte values that represent the keyword. And this next sentence has a caveat. Basic09 creates three tables during the compile: variables, line references, and other comments, basically. These tables are used to give each line reference or variable reference an offset address in the compiled code, and the comments contain more than just comments. It includes blank lines, line numbers with no line reference, as well as literals, which are Basic 09's version of constants. If you understand how Basic 09 interprets the code, you have a much better understanding of what makes good code structure in your source code files. Some Basic 09 programmers do not understand iCode, but some do. I recommend learning more about iCode as it will increase your understanding of efficient coding in Basic 09. Efficient code is not just code that is correct or compiles without errors. It is code that produces the desired outcome with the least amount of code and the most efficient statement structure to produce the most compact code. The smaller the code, the faster the program executes. The caveat to that sentence about the tables is I have not determined the number of tables and what they contain to be absolutely true. I am awaiting confirmation. I am certain of the variable list table and the line reference table, but not the third table, or whether it is a single table or multiple tables. File name extensions. OS9 and Nitros 9 do not require file name extensions, but you can use them if you feel the need. The .bas extension is the predominant extension for basic program files. I use .bo9, and it's pronounced .bo9, but you can also call it .b09 if you like, for Basic 09 source code files to show that they are not basic program files and to distinguish between the source code text file and the compiled iCode procedures in the Basic 09 workspace and the packed modules. This means that when you pack your procedures, they are written to your current execution directory. With single procedures, the file name of the packed module is the name of the procedure in Basic 09's workspace. For merged module files, if no file name is provided, the file will be named with the first procedure name in the workspace. If a file name is provided, the file will use that name for the file name. So now I will show you an example in VCC. You notice there are 3 procedures in the workspace. If I type pack all, then it will pack all 3 of those procedures into a file named test type in the current execution directory. If I type pack all, and the asterisk stands for all. If I type pack all and then say test param, then the file will be named test param, but it will still include all 3 of those modules in the order in which they occur in the workspace. I can also give it a completely different name, but that could result in problems because when it loads the modules, it's looking to run a module with the file name. So if I just, for example, named it test P, it might not work. It'll pack the files into a file named test P, but there's no guarantee that it's going to operate properly because there is no module named test P. So just to remember that. Okay. Now back to the file. Support files. Support files include any file used to aid a program in performing its job. These files don't need file name extensions, but are usually located in a directory dedicated to the program. For example, my program decode has its support files located in a data directory at the root level of the disk. There could be other programs making use of the data directory, but I have not found one. They are usually in a subdirectory of the program's default directory. For example, if your program uses a specific directory for its output, not the current data directory or the root directory, support files may be found in a subdirectory of that directory. So what it means is you can have your support files in a specified directory, in a subdirectory of a specified directory, or in a subdirectory at the root level of the disk. Statement stacking. The use of the backslash character is not telling Basic09 there is a new line. It is telling Basic09 there is an additional statement occurring on the same line. It is the equivalent to the colon in BASIC, which is called a statement concatenator. It concatenates multiple statements on one line. The same as in BASIC, you can use the backslash character to put as many statements on one line as you want to, provided you don't exceed the maximum allowable length for a statement line, which is 256 characters. Variable declaration statements. Basic09 allows type, dim, and param statements to occur anywhere in the source listing in any order. The only requirements are variables be dimmed or parammed before use, as doing otherwise will result in multiply defined variable errors and other errors. Type statements occur before the variable that is declared to be that user-defined type. Doing otherwise will result in errors, as occurred in the 3 test procedures shown earlier in this video. Remember, make sure the order of your type, dim, and param statements is correct. Now, to add to that, there is a reason why defined by use variables exist and why they are only 2 types. It is to prevent additional errors. If you, for example, define a string as my string with a $sign, and you forgot or misspelled that in the type, dim, or param statement where you declared it, it will be determined by Basic09 to be a 32-character string defined by use. If you have a variable name such as my variable and you misspelled it in a type, dim, or param statement where you had it defined as, say, an integer, it will be defined in Basic09 as a defined by use real variable. The string variables are a bit more difficult to find because they don't produce an error. The only way you know there's an error is when you get output that is not correct when you run the program. With real variables, it's pretty much the same, except that it's easier to find them because all you're doing is looking for a variable that only occurs once in your source code. Unless, of course, you misnamed it multiple times and it was the type, dim, or param statement that was correct. That said, it is a way to catch them without creating further errors. What will generate an error is if you have a string variable defined in a type, dim, or param statement that does not have a $sign as the last character, and then you misspell that name in the source code where you use it, it's going to generate a wrong type. I believe it's a type mismatch error because you're trying to assign a string to a real, or you're modifying a string that is seen in Basic09 as a real, and that will generate errors. Those are the easy ones to catch. So just be careful about how you declare your variables and try to make sure you don't misspell one. Okay. A caveat on parameter passing between procedures. Basic09 has a peculiar ability that I've never seen in any other programming language. You can pass multiple variables to a procedure and receive them all in a single variable as long as the types of data match the receiving structure. The only requirement is that the total size of all of the parameters matches the size of the receiving variable. One thing I did not include in there is if the receiving variable is a string, you can have mixed types because all of it will be converted to a string. An example is passing 5 variables of mixed types with a total size of 32 bytes to a receiving procedure with a string variable defined as the parameter. Another example is passing 5 real variables into a 5-element real array. So as long as everything is correct, you can do that. I don't know too many reasons why somebody would want to, especially with the string variable version, but you never know. I leave it to the programmer to decide if they need to do that or not. Statement line length. This file is saved as a .bo9 file to show what I consider to be the appropriate length of a statement line in Basic09 source code. It is set to a width of 79 characters. Basic09 wraps statement lines at 64 characters, and the editor will have difficulty editing the code at the wrap point, as well as difficulty displaying the entire line once the statement is over 90 characters. The entire statement is still there, even if it can't be displayed correctly or edited properly due to its length. The width is also set to 79 because the text windows in OS 9 and Nitros 9 are 80 characters wide, and the 80th character will always wrap. I reserve the 80th column for carriage return characters whenever possible. As was stated previously in this video, the maximum length for a statement line in Basic09 is 256 characters. So you need to be careful when you're doing your statements. If you can possibly break up a long statement into multiple shorter statements, I advise doing so. Use of parentheses. It is a good practice to use parentheses around all expressions that use or, and not. But you must be careful to ensure that you do not place them incorrectly. For example, expression 1 or expression 2 in parentheses and expression 3 will evaluate the or first. Basic09 will strip these as unnecessary since and or operations are evaluated in the order of occurrence. Expression expression 1 or expression 2 and expression 3 in parentheses, we'll evaluate the and first, and then the or. Basic 09 will not remove these parentheses as they are required to ensure the and is evaluated first. Remember, when using parentheses around all occurrences of or, and not, make sure you are not putting in parentheses incorrectly, because you could end up with an expression being evaluated out of the correct order. My program decode wraps parentheses around all occurrences of or, and not, and lets Basic 09 remove the unnecessary pairs. The reason it can do this is because it uses the I code in the packed module to retrieve the instructions from, and the order is already correct in the I code. About I code. I code in Basic 09 is stored in what is commonly referred to as RPN, or reverse Polish notation. Some people may be offended at this name as it can be seen as racist. The proper name for this is postfix notation. Infix notation is the way we normally enter an expression, a equals a plus 1, for example. Postfix notation is like this, a equals a1 plus. Okay, show an example in VCC. I got to remember what I was going to do there. Okay, I can't really do that in VCC, so I'm going to skip that. I pretty much did it here, so I didn't really need to do it there. Line numbers. Line numbers do not use more memory or slow the program down. Their use in Basic 09 is optional and only need to be used in any case where there is a keyword that uses a line number as a branch location. Examples are go to 10, go sub 100, on error go to 1000, on expression go to 10, 20, 30, on expression go sub 40, 50, 60, restore 50. The restore keyword does not require a line number. It is used with the data statement. Restore without a line number resets the data pointer to the first element of the first data statement. If you have multiple data statements, you can use line numbers to set alternate restore points, which then requires the line number with the restore keyword. Used in that way, the data pointer will be moved to the first element of the data statement that occurs at the offset address indicated by the line number. I hope that makes sense. About line numbers. Line numbers in Basic 09 are essentially labels. They are the only form of label allowed for assigning branch locations. Branch locations in I code are hexadecimal 4-digit addresses indicating the position within the code to branch to. Use of else if then. While it does make the source listing slightly shorter, using else if on the same statement line affects readability and makes determining indentation more difficult. The examples I've included are, first example, if expression 1, then do stuff, else if expression 2, then do stuff, else do stuff, end if, end if. You notice the indentation. Right? The first example is harder to read than the second example and can make indentation errors, which are missing block termination statements, harder to find. In the first example, the first else aligns with the first if. After that, it gets weird. The second else aligns with the S in the first else, not the second if. the first end-if aligns with the S in the second else, not with the E at the beginning of the second else. The second end-if does not align with the first if or else at all. This can become problematic when you have a long list of if-then, else-if statements. Now, the second example, if expression 1, then do stuff, else. If expression 2, then, else, do stuff, end-if, end-if. The second example shows proper indentation for each block level. Sometimes you will see if expression, then statement, \endif on a single line. It can be handy when there's only one statement between the if and the endif, but it can make it more difficult to find missing block terminators. The same is true of for counter equals a number to some number \next counter statements. They are great for timer loops, but they impact determining missing block terminator statements. And I did not include here, and probably should have, there is another if-then type that will have a similar impact to determining terminator blocks and indentation. And it is the if-then line number statement. If-then line number does not have an end-if terminator. It is a branch instruction that branches to a specified line number. I'll cover that more later down in the video. Using goTo or goSub to branch to another procedure. This is impossible. Any line reference not found in the local procedure is flagged as an error. I am surprised that Jason had to tell AI that this is a don't do. Even if the line number is correct for the other procedure, Basic09 will only look in the current procedure for the line number. If it isn't there, Basic09 will generate an error. If it is there, you will get unexpected results. Remember, to call another procedure, you must use the run statement with any parameters contained in parentheses, with each parameter separated by a comma, and any string literals, constants, within double quotes. Initializing variables. While many variables should be initialized at the start of the procedure, not all variables should be. Also, given OS9's and Nitros 9's limit of 64K memory available to a process, overuse of this can lead to out-of-memory errors if the procedure is or group of procedures packed together are large enough. Okay, so this is where I use my decode, and I had that, I don't know why it didn't get saved. I had that in my in this file earlier yesterday. Source decode. Okay. First, I'm going to show you the way. Let me turn the wrap off on that file. This is the way I normally do my procedures. I start with comments at the top that tell you about the procedure, in this case, the version number. Then the section. This section is declarations. And then the first declaration is the variable record and the variable array. Then the file record, then the line reference record and its array. Then the second file record, which is the first line file record up here is actually kept in memory, and it's a, oh no, that's the file record. This one is the array that's kept in memory that has a portion. And the reason is, if you look at this type statement, that one type statement is composed of 4 separate type statements. Why? Look at how many variables there are. In order to make sure that I wasn't going to have problems dealing with these declarations, I found it better to break that single type statement into multiple type statements and then create a type statement that contains all 3 of the previous ones, so it creates one single record. And with the file record for the file, this is all that's in it. Okay. And then the line reference record is also an array of 300. Then I have what I call my data section map. It's actually the description area. I also call it the DSAT, which is where DS came from. DSAT stands for Data Statement Allocation Table. Anyway, then I have colors, then I have registers. And once I've got all the types dealt with, then I do the dimension statements for all the local variables to the procedure. And you'll notice there's a lot of them. So I have them broken into groups with a comment that tells you what each group is about. And I have them in the order byte, Boolean, integer, real if I have any, and string. And then the strings are mostly in order by size from smallest to largest, or shortest to longest, if you want to see it that way. And then the single parameter statement is an 80-character string, and it's the path to the packed I-code module file that it is going to be decoding. And then I set it to base 0. Then I get the term packet for the current window. And then these are the only initialization statements that I define here. There are others, for example, as it does all these for knowing which file and everything. But most of those are kept in support files. So I get those down here. I actually define them there. I write them to the file, and in other procedures I load them. And then on these, they get incremented as necessary. So I have format strings for print using. I have a number of different windows that may or may not be displayed depending on your preference settings. And then I have things like this. And so these are all examples of ways you can try to minimize your code, because it's not really going to make the packed module that much shorter. It's going to make the source code file shorter. And the reason that you want to do that is because you could end up with a source code file that's like 40, 50K long, okay? And you load it into Basic09, and it compiles in at 34K or 36K. Okay? Okay? Whereas by doing it this way, maybe your source file is only 35 or 40 instead of 50 or 60. So that's the reason for doing that. And I think that gives you a better example of more efficient coding. Now, that doesn't mean that decode is as efficient as it could be, because it isn't. I'm still working on it. Okay. String variables. The use of the $ character is only required if defining a string variable by use, and that variable has a default length of 32 characters. Excuse me. If defining string variables in type, dim, or param statements, the $ is not required, and the use of the atomic type string without a length modifier results in a 32-character string. Examples: my string. Now, I normally pronounce the $ as string. That's just my habit. So, my string, defined by use, 32 characters length. Dim my string, string. $ is optional, 32 characters length. Param my string, string. No $ character, and it's 32 characters in length. Type my type equals my string, string 64. No $, length modified, 64 characters length. Now, these are all valid examples. You can try it yourself. Every one of them are valid. Your preference of how you want to name your strings is up to you. I personally do not use the $ because that way, if I misname a string variable somewhere in my code, I'm going to get an error and it's going to be easier to find. So that's just my preference. Okay, terminating a procedure. The end statement is only required to occur at any point in the code where the procedure is to end. If the last thing in a source listing is a return statement, no end statement is required at the end of the listing. If your procedure has an error trap as the last code in the procedure, then an end statement is usually required if there are fatal errors being trapped. And what that means is if you're trapping errors and one or more of those errors is not something that you can deal with and then return execution to another point in the code, then that would be an error that you would want to end the program with so that you can determine what the error means and figure out what you have to do to correct it. So it's up to the programmer to determine which errors are fatal and which are not. Okay. Error traps. Best practice is to have a single error trap in a given procedure. While multiple traps can be used in one procedure, this makes the code less readable, harder to track down issues in the code, and usually requires overuse of the goto statement to jump past error code blocks. So I had transpile there also. I guess I'm going to find that one now. Okay, I'm using transpile 0 because that was the previous version before he started trying to break it into multiple procedures. So what I'm going to show you here, he has the error set to go to 900. Instead of using it, he sets error code equals 101 then test the length of the source file path string to see if it's 0. And if it is, print this error message, set the error code to 101, and then go to 900. Now the problem is these two statements are never, or these three statements are never going to be executed. Why? Because the on error is already set to 900. When it gets here and it tests for the length of source file path string, it's going to generate a parameter error because a zero length string means no parameter. It will automatically go to 900. Okay? It may process this error code message, but if you go down to 900, way down here, okay, print runtime error code error. Okay, so this is the error code it was given. This is the error message. Okay. Then he has, if the error code is 101 or 102, then print this usage. Now that will get printed because he did pass error code 101. But he did not pass error code 102 because he didn't change it before he tested for target file path string. Okay? So it won't print this, or well, actually it will, but it won't. Error code will never be 102. Okay? Then he closes all the files, or any files that are open, and ends the program, which is fine. Okay? However, as I said before, these lines between if and endif are not going to be executed if there's a parameter error. Oh, he did put error code 102. Okay. So the help message will be printed out. But anyway, basically these if-then tests were absolutely unnecessary. Right? He should have put these print statements in the error trap at 900. Okay. Now down here, he has error messages for loading the contents of the support files. Right? And I've got to see. Yes, he has on error go to 110. Okay? So he changed it from 900 to 110. You come down here to where 110 is, and just before it, he has a go to 119 just to skip past this. 110 then checks for an error, an incorrect error. It checks for 210. It's not going to get a 210 error because the file not found error code is 216. So these will not be executed, but it'll jump to here and it'll say system error, right? Which is totally misleading because it was just file not found. Right? And then he closes the file here and then goes to 900. Right? And he does the same thing with the constants file, which is another support file. He jumps past the error block with go to 129. He also set the on error go to 120 before he started this part. And it's basically the same code with the same wrong code number. Okay? And he goes to 900. And if the error didn't happen, he jumps past it. Okay? Then he's got a third file, variables, where he, did he set the on error on that one? Yeah, on error go to 130. So you jump down here to 130 and go to 139 to jump past it. Again, the wrong error code, so it's going to do this, right? And then it's going to go to 900, right? And tell you it's a system error, not a file not found error. And then he starts his main loop. Okay? And he sets on error go to 140. Okay? Well, you come down here to 140. Where's 140? Oh, here it is. Okay. Then he tries to delete the file. Counting on a file doesn't exist error to he has it doing a system error deleting target file. Okay. And then jumps to 149, which it does if the error didn't happen, and creates the file. Right? That's not really the best way to do it. And then, of course, he resets on error go to back to 900. I created when I was helping to figure out how to make this more efficient, I came up with my own file. Right? Now, this is the length of this file, 4,365 bytes. Notice the size of this file, 17,429. Right? That's a big file. And loaded into Basic09, the data memory requirement is over 29,000 bytes. Okay? For convert, it's less than 1,000. Now, I only set the on error one time. Okay? I have two error code flags. ERR code, which is the error number that ERR returns, and an error code number that tells me which file it was that it errored on. So you can see here, if it's on the types def file, the error code is 1. If it's the constants file, it's 2. If it's the variables file, it's 3. If it's the parameter string, or the first parameter string, it's 4. Or it's error code 4 and parameter error 2. If it's the target file, it's still error code 4, but it's parameter error 3. Okay. Now, I believe up here is where I had, parameter error equals 1. Okay. If the folder path string is not there, it's going to error out and go down to the go to the error trap. Otherwise, it looks to see if there's a slash before the path string. If there isn't, it adds 1. So now let's go down to the error trap, because that's all the code related to errors except for the error trap. You'll notice my error trap code is a bit longer, but it only gets executed in the case of an error, so it needs to be at the bottom of the file where it's not going to be accessed that often. First thing it does is set ERR code to the error. Then it looks for error code 216. And if error code is equal to 1, then it says types B09 doesn't exist. If error code 2 is equals 2, then constants doesn't exist. If error code is 3, then variables doesn't exist. And if error code is 4, then source file doesn't exist. When it comes to the parameter error, if parameter error is 1, no path for defs file. If it's 2, no path for source file. If it's 3, no path for target file. Right? And these are all fatal errors. Right? Once it gets past that, if there is a target file path string parameter, but the file already exists, which is a 218 error, then it deletes the target file and goes back to line number 10 to resume execution. Right? For all the other errors, it's a fatal error, and it prints out the error code, and then checks to see if any files are open and closes them if they are, and then ends the procedure. So let's go back up to 10. Oops, not 110. Okay, line number 10 is the create statement for creating the target file. This was much less code than what it took in transpile. Okay? That alone reduced the code significantly. Okay, hold on 1 second. I needed to take a drink of apple cider. Okay. File not found. The file not found error is 216, not 210. 210 is a boundary error. Refer to the OS9 or Nitros 9 user manual and technical reference for more information on system errors. The most common errors associated to files in Basic09 are the 216 error, the 214 error, file already exists, and the seek error 247, which usually means that you specified a drive that had no disk. Those are really the only errors I ever run into in my procedures where I'm dealing with files. And I think in convert I put the wrong number down there. I think I said 218. I did. Okay, let's find out what the actual error code is. .214 is no permission. 218 is file already exists. So I had it wrong in my notes. It's 218, not 214. Okay. Anyway, so the no permission error can also happen if you're trying to write to a file that doesn't have write permission. So you might want to keep track of that error if you're trying to write to a file. Which usually means open the file that you're going to be writing to in update mode or write mode. Okay, logging. Logging is a good way to see where problems in execution occur, but the memory constraints of OS9 and Nitros 9 can make this impossible when procedures or groups of procedures packed together get too large. Remember, pay attention to how big your procedures is or are getting, and adjust your logging code to prevent out-of-memory errors. Also, remember to remove your logging code when you are ready to distribute your program to reduce the program size as much as possible. In decode, I have to pack the modules and run them from the command line because decode is too big to run in Basic 09. So in order for me to figure out where errors are going on, I have to include some kind of debugging code. What I do is I include a string variable whose entire purpose is to tell me the last place that string was assigned a value before an error occurred or before I got bad results. I just move that string assignment and change the content of the variable as I move closer and closer to the point where the error is occurring. That way I narrow down where in the code to look to find the problem. With multiple procedures, in order to know if the error occurred in a procedure being called through a run statement, I have to add the same error coding or debug coding through the parameter list so that whatever happens in there, it gets returned to the calling procedure and can be reported through the error trap. So that's how I do it. And it works. It just takes longer to find a problem because I can't put different assignments at different places at the same time. I can up to maybe 2 or 3, but for the most part, I'm limited to 1. Okay? And it works, but it does require extra code, and you have to be able to know what you're looking at. So, okay. Unique variable names. Unique variable names are only important within a procedure. You can have variables with the same name in different procedures. So what that's about is, excuse me, for some reason my throat is itching badly this morning. You can have variables with the exact same variable name in different procedures. You cannot have variable names with the exact same name in the same procedure. That results in a multiply defined variable error. Okay, switch case. Switch is the name used in C and maybe some other languages. Some versions of BASIC have a select case syntax. Basic 09 does not have a select case structure. The use of if-then-else only partially suffices for a select case workaround. The switch or select structure has what is called fall-through syntax, where multiple cases can result in the same code being executed as follows. Select expression. Case 1, case 2, case 3. It will fall through all of those until it reaches case 3, and whatever is under case 3 will be executed, regardless of which one of those cases was true. Then there's a break statement so that it ignores case 4 and default and goes to InSelect and continues execution after the select routine. Case 4 has to specifically be true to do what is within that case. And then it also will break and skip past default. The default is, well, it occurs in every single switch or select structure I have seen. And what it does is if all of the cases above were false, then it will execute whatever is in the default case. The break statement that I have there is not in every version of switch or select that I have seen. I have only seen one or two, and I can't remember which ones they are, that had a break in default. Usually, whatever the last case is, and it's usually default, doesn't need a break because InSelect is the very next thing. But some versions may require it. Every version of switch and select I know of contains a default case. This is code that is executed if all previously named case statements are false. Default may or may not require a break statement. The workaround for fall through is to use a form of if-then other basics don't have, if-then line number. An example is, and I talked about this a little bit earlier, this example is how to do a switch or select case that includes fall through in Basic09. If expression 1, then 200 is the equivalent of case 1. If expression 2, then 200 is the equivalent of case 2. If expression 3, then, is the equivalent of case 3, and this evaluation does not occur if either of the two previous expressions evaluates true. 200, do stuff. Okay. Then else. This else won't be executed if any of the three previous expressions evaluate true. Execution will drop to the first instruction after the second endif. Okay. Then under the else, if expression 4, which is the equivalent of case 4, do stuff, else, and this else clause is the equivalent of the default clause, do stuff. Okay. Then the two endifs. The second endif does nothing unless the third expression evaluates true. It basically ensures the stack is cleared. And I know this is true because I've used it. Now, I don't generally do the else part. The one time that I've done this, it was 3 if expressions, then line number, and then the fourth one was if expression, then. The line number is, or the number with the line number, is the first instruction after the if-then statement that does not have a line number. That allows the previous if-then line number statements to jump past the one that does not have a line number. And in which case you have an endif that basically isn't doing anything. The only thing it does, and just so you know, in iCode, it is 2 tokens. 1 token for endif, 1 token for end of line. Okay? Or in the case of this one, because there is a backslash character, a 3E, which is end of statement. Right? So all that happens when it gets through with whatever is within that expression, or within that if expression, then end if, when it reaches the end if, all it does is go to the next instruction. Okay? It just makes sure the stack is cleared and goes to the next instruction. So that's how it works. Now, I don't really recommend doing it this way, simply because I like to try to find better ways to do things, because sometimes this may be the only way you can get around the problem, because otherwise it's if expression then, or if expression, or expression, or expression, or expression, okay? And you could end up with 6 or 7 expressions separated by ors just to go to the next line and execute 5 or 6 statements. Okay? And the only other way to do it is to do a if then end if for each one and put the same lines of code, no matter how many they are, within each if then end if structure. And that's a waste of code and unnecessary duplication. So basically, you have to figure out what's going to work best for you. Now, the underscore character. This character is generated on the Cocoa using Alt Dash. I don't have a real Cocoa anymore, so I may be mistaken about that. Someone else can verify which key sequence it is for producing the underscore character. But as far as I know, it's Alt Dash. Now, procedure and variable naming conventions. Basic09 doesn't care what case or characters you use in procedure names or variable names, so long as they are within the scope of accepted characters for procedure names. Accepted characters. For procedure names, they must only contain valid file name characters and be no longer than 29 characters in length, the maximum file name length in OS 9 and Nitros 9. For variable names, they must not include reserved characters, $, unless a string, any operator. There may be others I can't think of offhand. And the maximum length of a variable name is apparently 32,767. L. Curtis Boyle posted this on the Discord in November 2023. We were having a discussion about maximum variable name sizes, and I stated that that I had thought that the maximum length was 29, but then I discovered longer variable names worked. And his response was, yeah, I was surprised by that too. I checked it when I saw the code basically allows up to a 32 character long variable name because of the routine it calls to assign the variable name into the variable name table. I tested up to around 160, changing only the last character of the two names, and it knew the difference. I wouldn't recommend making variable names that huge, since that takes away from program and variable content space, but you can make them pretty well as big as you want. 29 characters is the limit of an OS 9 file name, which may be what you were thinking of. So, and on that note, I recommend variable names no longer than 15 characters. It makes it easier when you have to stack multiple statements on a single line, especially assignment statements. And it also makes the code more readable because most of your variable names are going to be very understandable for what they are and what they do in 15 characters. That said, you may find some that actually require a longer name to be that descriptive. In those cases, I suggest that you use a shorthand version that falls within 15 to 20 characters maximum. As what I have done with a couple of my programs, I include with the program, for those people that may want to be checking out the source code, a text file that contains a list of all of the variables within the procedure by name with a description of what they do. That way, if somebody doesn't understand the abbreviated form, they can look in that file to see what that file or that variable name refers to. And the same goes with file names. Okay? Make sure you can have a path of up to 80 characters. Actually, it can be longer, but 80 characters is usually all you need. Just make sure that the file name at the right end of the string is not longer than 29 characters. Okay, in conclusion, this is everything I found in Jason's video that I felt it necessary to comment and or elaborate on. I hope it helps people who are not as proficient in Basic09 coding to write better and more efficient code. Takeaways are: pay attention to the code that you are writing. Make sure that it is not only correct and compiles without error, but that it is the most efficient code that you can write. Don't worry if you can't produce the most efficient code possible on the first try. It takes time and many rewrites, along with implementing something you just learned that you didn't know before, to create efficient code. The emphasis is on trying. If you set your goal to write efficient code, you will write as efficient of code as you are able to at that time. Test your code in Basic09 frequently. If the procedure won't run in Basic09 due to being too large, greater than 32K, pack the code and run it from the command line frequently with logging code to tell you where the errors are occurring. The longer you wait between test runs, the more errors you will be dealing with. Keep the error count to a minimum of 2 or 3 errors at a time to make it easier to debug your procedures. And that is the end of this presentation. I want to thank everybody who is watching this. And if you made it this far in, thank you very much for watching the whole video. This concludes this video, so I will see you in the next one. Bye.